in this problem we're facing something we've seen before, where we have a box on a ramp with a rope connected to a pulley that has the force P in two directions and friction. However, what's different in this problem is the box is moving, so it's going to be dynamic, it's going to have acceleration. And in the problem statement, it tells you that the acceleration is 5 feet per second up the ramp. So that tells you, if we're using this coordinate system, that this acceleration is equal to 5. However, you also know, given this statement, that your acceleration in the y direction is 0. And that will help us because when we make an equation, the sum of the forces in the x direction and the sum of the forces in the y direction, one of those equations will be static because the acceleration equals 0. Another thing I want to point out in this problem, now that we're working with MA, is that the weight they give us in English units is in pounds. And that weight is connected to the mass, but it's not the mass. We need something that's equivalent to kilograms. And to do that, you divide by 32.2 and you get slugs. The only time you'll ever deal with slugs is when you need mass in English units. So don't worry about trying to figure out what's going on there. Just remember that mass in English units is a slug, and you just divide the weight by acceleration to get that. Alright, let's get started. Sum of the forces in the x direction is mass times acceleration, and as I did before in the previous video, I'm going to divide this up to where the right side only deals with acceleration and the left side only deals with forces. And we have the force is P plus P cosine of 30 and minus the weight times sine 30 minus the normal force times mu of k equals mass times acceleration in the x direction. Do be sure that you have the sines and cosines correct. It's pretty easy to mess up, so make sure you get those correct or you'll get the wrong value for the answer. And we'll plug in the values and simplify. So P, which is our unknown, is 1 plus cosine of 30 minus 100, which is the weight that we are given, sine of 30, minus normal force, which is also unknown, times 0.25, and that equals the mass, which is from weight, which is 32.2, times the 5 feet per second. Now, we have two unknowns in this equation, the normal force and the pull force, and that immediately tells us that we need another equation. And our next equation is easy because it is a static equation. Sum of the forces in the y direction equals 0. And in the y direction, you have the normal force minus the other component of weight plus P sine of 30. And once again, be sure you get those values right. When you solve for n, you'll find that it equals W cosine of 30 minus P sine of 30. Plug this in up here and simplify to solve for P as well as n. Or you can use a program that allows you to do simultaneously solving like Wolfram Alpha or MATLAB. And n equals 64.7 pounds, and P equals 43.8 pounds. And that is our final answer.